technical problem on Google Chrome. So, okay. We are back now. We are back online. Do you hear me, class? Naririnig niyo ba ako?
Yes, sir.
Yes po, sir.
Yes, po.
Yes po.
I-attach ko lang yung file. Okay, here now. Last time I discussed conservation of momentum. Okay, here. Okay. As a review, application of momentum is for bodies. So, this body number one, given a velocity v sub 1, direction is to the right. Okay. Body number 2, given a velocity v sub 2, direction is the opposite, to the left. To each other, there is a point where they interact or touch each other or hit each other here. This the during hitting or during collision. Now, this velocity, they are vector quantities. So we call this diagram velocity diagram. Okay. During the collision, there will be no velocity. Velocity will be zero here. Stop, they will stop. And that velocity, because of the interaction or collision, is converted. Internal forces is converted to external forces. Okay. Now, since body number 2 hit body number 1, the force that body number 2 exert goes through. Okay. Tumagos sa body number 1. So this force is produced by body number 2. So we call it F2 on 1. That means this subscript 2 on 1 is subscript 2 refers to the body number 2. So this force now is produced by body number 2 exerted on body number 1. That's why it is F2 on 1. At the same time, this force number 1 also exert a force. And that force hit body number 2. So that force now goes through. Tumagos sa body number 2. So we call this force now F1 on 2. That means this force is produced by body number 1 exerted on 2. Okay. So you must understand now how to identify the forces. Okay. right after the collision or hitting, okay, these two bodies separate. They bounce away from each other. So if the velocity here is denoted by V sub 1, capital letter E, after the collision, the velocities are denoted by capital letter U. So the velocities after the collision is U sub 1 and U sub 2. You will not before that V sub 1, this body number 1 is going to the right before the collision. Now, because of bound back, the velocity of this body number 1 will be in the opposite direction from that. U sub 1. Also here in body number 2. So we have derived before, okay, for the conservation of momentum, the plus the m2 v2 is equal to the momentum after the collision. It's m1u1 plus m2u2. That is the formula for conservation of momentum. Okay, here. Yan. So this is very important. But easy to memorize. Moment before collision equals momentum after collision. We also discussed before collisions. Okay. When there are three types of collision: perfectly elastic collision, partly elastic collision, and inelastic collision. This collision, partly elastic, equals 1, and for partly elastic collision, the value of E is greater than 0 and less than 1. Okay. Now, how to apply this? Okay. We know already that so if this will be the case, the value of E is equal to 1. Therefore, for elastic collision, this formula equals relative speed after collision divided by relative speed before collision. This will be equated to 1. Okay. For elastic, equals 1 ito. Therefore, we can say that the relative speed before the collision is equal to the relative speed after the collision, because if this is 1, by cross multiplication, this relative speed is equal to the relative speed here. Okay, that is how to use this formula, because for partly elastic collision is equal to the ratio between relative speeds. Okay. Okay. Supposing the collision is Inelastic. Pag inelastic ito, E equals 0. So we cannot use this equation. If inelastic collision, we have to use this conservation of momentum formula. Okay. We cannot use the formula for A because 0 ito. Yun. Okay? Any question about that class? Okay. Ballistic pendulum. Ballistic pendulum is a device used to measure velocity of bullets. A bullet with mass m and with unknown velocity v is fired to hit a hanging block of mass m. The block is embedded. The block with embedded bullet swings and rises to a height h. Now, this ballistic pendulum is also an example of conservation of energy. This is one half the figure for the simple pendulum. The simple pendulum is until here, swing back and forth. But ballistic pendulum is only half of that. Okay. So, since this bullet is fired before the collision, it has a velocity v sub 1. Okay. There. So, the other mass, which is a hanging block, this is made of block of wood, which is suspended by means of a string, and it is at rest because it is just hung from the ceiling. So the velocity of this block is 0 because it is resting. Okay. So we have B sub 1 and M sub 1 for the bullet. For the hanging block, it is B sub 2 equals 0 and M sub 2. During the heating or during the collision, okay, it will hit the block. The bullet will hit the block. So there will be already this bullet, because of the velocity of the bullet, force is present now during the collision. That velocity is converted to force, internal forces. Because of the force, you will note that in order to change the position of the body, you have to apply a force. That's why it's a force. Because of that force, the body moves, it swings because it's tied with a string. It will follow a curved path, okay, swing, until the block reaches the maximum position, maximum height. Now, since it's a bullet, it is embedded. Okay? Pumasok sa loob. So, in the process now, if they travel in this path, the mass now will be the sum of M1 and M2 kasi magkasama sila because the bullet went inside the block. Okay. Okay? So, if we apply the formula conservation of momentum, M1V1 plus M2V2 plus equals M1U1 plus M2U2. This is the formula. There. Now, knowing that before the collision, the velocity of the block is zero. So, this term now becomes zero. So, M1V1 equals M1U1 plus M2U2. Okay. But when the bullet is embedded here now on the block, on the final condition, okay, the mass, okay, of the bullet here is M1 and the mass of the block here is M2. And they join together. There is a form one body. So M1 plus M2, we can put this as capital M. Okay. Also, the velocities here. The final velocity of the bullet is u sub 1. The final velocity of the block is u sub 2. And since the bullet is inside the block, they have a common velocity. That is capital letter U. Or U1 equals U2 equals U. There. U is the common final velocity. So, substituting this now in this equation, M1V1 equals M1U plus M2U. So we since U is common to both terms, so we will factor. Okay, U it is equal to M1 plus M2 times U. Okay. U is the final common velocity. The equation for this final common velocity now will be established or derived from the conservation of energy. Okay. The equation for the conservation of energy is the maximum potential energy here is equal to the maximum kinetic energy at the lowest point. There. Okay. So, kinetic energy maximum here equals potential energy maximum on this point. Okay. So what is formula of kinetic energy? 1/2 mv squared. Okay. It's equal to 1/2 mu squared. So that is the final common velocity. This is equal to the maximum potential energy here at maximum height. So it is mgh, where h is the maximum height. This distance from the zero elevation to the highest position the block will reach. Okay. So, knowing now the equation 1/2 mu squared equals mgh, cancelling m here both sides of the equation, we have 1/2 u squared times equals gh, and u is equal to the square root of 2gh. 2 is put to the other side by cross multiplication. So we have now the equation for the final common velocity U equals square root of 2gh. And substituting here now, this term now is here. We have M1B1 equals M1 plus M2 quantity multiplied by square root of 2gh. There. Therefore, the velocity of bullet now is B1 equals M1 plus M2 divided by M1 times square root of 2gh. So this is the velocity of the bullet. Okay. That is how to solve or determine the initial velocity of the bullet here. May tanong ba kayo?
Wala po, sir.
Okay. So again, we have a procedure again in dealing with conservation of momentum. Same as conservation of energy. Meron tayong procedure. Okay. Yan. Okay. If you draw a figure, you have to identify. Okay. Here. Before, during, and after the collision. You have to do like this. Because in collision, laging mayroon ito. Okay? The situation before the collision, the situation during the collision, and the situation after the collision. Okay. Also, we use the why we use the energy equations here, because there is motion. Okay. If there is motion, there is velocity. So, kinetic energy is involved. There. In this case, since a force hit this body and it is displaced at the position changes from this point to that point having a height. So because of the position or elevation, there is potential energy. Okay. So we can say also that at any point here, for example, between this point and this point, merong point A dito, we have also the energy equation equal to the kinetic energy here plus the potential energy here is equal to the maximum kinetic or maximum potential energy here. So that is how to establish the equation. Okay. Okay, we'll go to the example. Oh, makinig na how to apply the conservation of momentum. Okay. A 2,200 kilogram car at 35 meters per second straight is stationary 1,500 kilogram car and the two lock bumpers. What is the final common velocity just after the collision? What percentage of the initial energy is dissipated in the collision? Now, the problem is saying there are two cars. Okay. One is big and the other is smaller. 2,200 kilograms against 1,500 kilograms. So, mas maliit ito. Okay. And the two lack bumpers. So, if this is the these are the cars before the collision. This car is 2,200 kilograms and the other car is 1,500 kilograms at rest. Okay, this is stationary. Okay. So, walang velocity vector dito kasi velocity equals zero. Okay. Only in the first body. So, this object now, this car now is given a velocity of 35 meters per second. That means in 1 second, 35 meters ang distance niya. Okay. So, if this body now, body number 1 now, get close to the body number 2, it hit, okay, body number 2 and that is hitting during the collision. Okay. During narito. So, at the instant, both objects, both cars stop. Their velocities are zero. And the velocity is converted to forces, internal force. Okay. So, this M1 now, this body number 1 now hit body number 2. Therefore, this force is 1, 2, F12. At the same time, body number 2, mass number 2 also hit because even if it is stationary, there is a force that resists that. And that force is F21. Okay. That resisting force of 2 on number 1, car number 1. So this is the force diagram. Okay. You notice here, we don't go away with forces. Okay. So after the collision, since the two cars lack the bumpers, okay, because of the size of this, the mass of 2,200 against 1,500 kilograms. Okay. So the tendency here now is the bigger car will hit. Okay, there. And because of the force exerted by this bigger car, this smaller car will be forced to go with body number 1. Okay, considering the size. Okay. And they will have the same common velocity, final common velocity there. What is the final common velocity? Okay, so that is after. So if we go here, this is considered inelastic collision and E equals 0. Okay, so if we put E equals U2 minus U1 over B1 minus B sub 2 equals 0, E is 0. Okay. So we cannot use this formula. We will use the conservation of momentum formula. M1B1 equals M2B2 plus M2B2 equals M1U1 plus M2U2. There. So this is the formula. Okay. Now, what will be, since the two lack bumpers, the U sub 1 here, final velocity of U sub 1 equals the final velocity of U sub 2. Okay. And it is U, that is the common final velocity expressed, okay, denoted by capital letter U. Okay, so U1 equals U2 equals U. So we can substitute now in the formula, since V sub 2 is 0, this term equals 0. Okay. M1 U sub 1 plus M2 U sub 2. Now, since this U1 is equal to U2 because is equal to U. Yeah. So, if U1 and U2 is equal to U is common, it will be M1 plus M2 times U. Okay. There. So for letter A, the equation for the final common velocity can be taken from this. It is M1V1 divided by M1 plus M2. And we have 22,000 times 35 divided by the sum. It is 2,200 plus 1,500. And the final common velocity is 30.18%. Okay. U is not percent, but meter per second. That is unit for velocity. There, meters per second. Now, for the energies, okay, since there is velocity, there's motion, there's kinetic energy. And question is, so the percentage of initial energy dissipated in the collision. So, computing for the energies, the final kinetic energy that is after the collision, the initial kinetic energy that is the before the collision. Since formula for kinetic energy is 1/2 mv squared, okay. So for the final, we have, since U sub 1 equals U sub 2 equals U, yeah, okay, 20.81 meters per second. So we have now 1/2 times quantity M1 plus M2 and of the quantity times K U is this, 20.81. And so simplifying, okay, the final kinetic energy is 801,153.78 joules. The final kinetic energy. For the initial kinetic energy, it is using the velocities before the collision, V sub 1 and V sub 2, but V sub 2 equals 0. So we have the initial kinetic energy is 1/2 is 0, 1/2 M1 P1 squared. Getting initial kinetic energy was 1,347,500 joules. Okay. Okay, so for the energies, now the ratio, energy transfer, that is the final. Okay. Kasi, and the original is initial kinetic energy. So if we get the ratio, this over this one is 0.59, 0.595 or 55, 59.5%. Okay, that's the ratio. So if we subtract 59.5% from 100%, okay, 40.5% of initial energy was dissipated during the collision. So this is the final answer. Okay. The kinetic energy is not conserved here because the type of collision is inelastic. E equals 0. Okay. So that is how to apply the law of conservation of momentum. See? Since the coefficient of restitution equals 0, we cannot apply the formula relative speed before the after the collision divided by the relative speed before the collision. Hindi pwedeng gamitin dito if this is 0. Okay. This is used only when equals 1 or here equals E is greater than 0 but less than 1. Any question, class? May tanong ba kayo? So this conservation of kinetic energy and conservation of momentum have similar approach. Okay. Making the correct figure first, then that energy equation, you have to write the correct energy equation. Now, the same problem, supposing the first example, the cars have spring-loaded bumpers so that collision is perfectly elastic. So, elastic naman to. Yung una, lock bumper. Dito naman, the bumper, they have spring-loaded. So, they will separate. That's why the collision is called perfectly elastic. So, we have the same diagram for the momentum before and during. Only differ is after the collision. Okay? So, retaining the figure before and during the collision, after the collision, this will be the velocity diagram. They will separate. Body number 1 will move to the left and body number 2 will move to the right. Okay. So, still the formula is M1V1 plus M2V2 equals M1U1 plus M2U2. But B2 is, B sub 2 is 0, so M1V1 is equal to M1U1 plus M2U2. Their initial velocities now is not common. Okay. So, From the energy equation, energy conservation equation, since velocity, since B2 is 0, so we have only 1 half M1 B1, 1 half MB squared, this 1 squared is equal to 1 half M1 u sub 1 squared plus 1 half M2 u sub 2 squared. Okay. Therefore, if we get now the equation of coefficient of substitution, there. For perfectly elastic collision, we have E equals 1. So, this will be equal to 1. If this is equal to 1, by cross multiplication, we have we have B1 minus B2 equals U2 minus U1. This U2 dapat ito U1 because the formula here, kung bumalik tayo sa formula, yun, U2 minus U1. Okay? So, take note of that. I-correct nyo yan. Okay? Baka mamaya, somebody will ask why naging U1 minus. Dapat ito, 2, yun, 1. Okay? So, boy, tama naman ito. If this is equal to 1, by cross multiplication, okay, U sub 2 minus U sub 1 equals B sub 1 minus B sub 2. So, we can get the equation of U sub 2, okay, since B sub 2 is 0, U2 minus U1 equals V1. And U sub 2 now is equal to B1 minus U sub 1. That is the equation for U sub 2. And so if we substitute here this to the energy equation, dito, dito sa momentum, conservation of momentum equation, okay, ang U2 is, dito iso-substitute yung U2. There. Okay. U2 equals B1 plus U1 equals 35. Okay. Dito pala, kukunin mo na yung U sub 1 from here. Okay. Okay, from the equation of U sub 2, we substitute in the energy equation. This is U sub 2. Okay. So if we simplify, okay, M1 U1 minus M2 B1 plus M2 U2, transposing or M1 B1 minus M2 B1 equals M1 U1 minus M2 U. That is the equation here. Okay, substituting. Yung U2 equals B1 plus U1. Sinubstitute dito. So, the term now, this equation now is expressed in terms of U1 and B1. Okay. Because that U2 is substituted by this B1 plus U1. So we have the final equation now for U1 from this equals M1 minus M2 times B1 divided by M1 plus M2. M1 is 2,200, M2 is 1,500 times the initial velocity 35 divided by M1, 2,200 plus 1,500. So we have U sub 1 is equal to 6.62 meters per second. So that is U sub 1. Okay. Now, from this equation, since U sub 2 equals B sub 1 plus U sub 1 is substituting 6.62 and B sub 1 is 35. We have 35 plus 6.62 equals 41.62 meters per second. So these are the final velocities. Okay. What is the velocity of the car after the collision? So final velocities. What are the final momentum and energies? Okay. So again, we know already the final velocities, U2 and U1. The energy now, okay, for body number 1 is 1/2 m1 U sub 1 squared. And since U sub 1 is found out to be 6.62, yun, squared. And this is equal to 48,206.84 joules. For body number 2, Ke2 equals 1/2 U2 M2 U sub 2 squared. And U sub 2 is found up to be 41.62 meters per second. And multiplying this, or simplifying this, it is 1,299,168.3 joules. That is the final energy. The final momentum, okay, here, momentum of 1 is M1 U1, momentum of 2 is M2 U2. So the final momentum now for 1 is 22,000 times, no, 2,200 times 6.62. Okay. Equal to 14,564 kilogram meter per second. For mass number 2, it is 1,500 times the multiplied by 41.62. There, the U sub 2. And this is equal to 62,430 kilogram meter per second. So these are the final energies and the final momentum. Okay. So you will not know the difference between elastic collision and inelastic. So dito, since elastic, ginamit yung coefficient of substitution formula equals U2 minus U1 over B1 over minus B sub 2. Okay. Then get the equation for a velocity here. Okay. Then apply the conservation. Okay. So we have already example on elastic collision and inelastic collision. Any question, class? Oh, ka-attend lang ni Bea Rico. So, you missed the 2 examples. Okay. May tanong ba kayo tungkol sa conservation of solving problems on conservation of momentum, sundan lang yung procedure na yan. Okay, do not Bea, pinalit ko lang po yung account. Okay? So, next time, Bea, better report earlier kasi you missed very interesting examples. Okay? How, anyway, may solution naman din sa materials, but I'm explaining it in detail para maintindihan ninyo. It's already 12:06, so lumampas na tayo ng 6 minutes. So we will meet again, we have the lunch break. We will meet again at 12:30. Okay, class?
Sir? Sir?
Yes. Emeline, yes.
May webinar po kasi kami ng 1 po. Required po, required po sumali po lahat. Kaya baka hindi kami makapag-lab mamaya.
Nang? Emeline, i-discuss na natin yung concern mo after the break. Lumampas na tayo isang oras dito sa unang session natin. We will meet at 12:30, okay? Emeline? So, see you at 12:30 class. Bye.
Sure. Sure.